Alexandra, back to you again with a fourth SPSS video over probabilities with z-scores. So remember, there is a difference between whenever we're trying to find probabilities in SPSS using the population sigma versus a t-test or test statistic, and I'm going to cover that in a separate SPSS video. So whenever we're dealing with probabilities with z-scores, that's when they have given us the population sigma, and from there we need to use that in order to find some sort of probability. So moving on into the two scenarios that we have in terms of finding probabilities in SPSS. So in this case, you don't need a specific data file to create a probability in SPSS. All you need is just to compute a new variable, no matter what your data file says. So in this case, you can use any SPSS file. It doesn't have to be the workers 200. I'm still going to use that one just because I'm lazy. And so yeah, I'm just going to use that one, but it doesn't really matter. So there are two scenarios whenever we talk about probabilities, like I said, and the first one is whenever the x value is given, or whenever basically within the parentheses is given to us, so this value. So the steps to find this probability in SPSS are given here. Transform, compute variable, CDF and non-central CDF, and then go to CDF normal. Because with CDF normal, we're assuming that this is a normal distribution using the population mean and sigma. So the nice thing about SPSS is that you don't have to standardize this x value into a z-score before you put it into SPSS, which is super, super nice. It'll do basically everything for you. So in this case, our example is we have a population mean of 28, a sigma of 13 or a standard deviation of 13, and we're trying to find the probability that x is less than 22. So remember, in SPSS, just like a z-table would, it gives you the cumulative probability, so the area to the left. So in this case, it's super nice because the inequality sign is already in the direction that we want it. So in this case, we can just plug in these relevant values into SPSS and it will find the probability for us. So let's go ahead and do that. So here we have just a random data file, doesn't matter, and we're going to go to transform, we're going to go to compute variable, and then now we just need to create the variable. So in this case, let's just call it a prob, and we need to go to CDF and non-central CDF, and we need to scroll down so that we get CDF normal. Remember, in the lesson, some of y'all made a mistake and clicked on L normal. Do not click on L normal. It is normal, just like this one right here. So you double click on this and it shows up here in this area called the numeric expression. So the instructions on what values you need to put in each of these question mark spaces is down here. Here it says quantity, mean, and standard deviation. So again, it tells you, it returns the cumulative probability with a specified mean and standard deviation will be less than quantity. So here it says very clearly, this is talking about less than a specific quantity. So like it says in our example here, what is the probability that x is less than 22? This is something that we can easily plug in to this SPSS and it will calculate this exact thing. So let's go ahead and do that. So we have an x quantity of 22. So that's the first thing that we need to put in here, 22. As we can see here, quantity is the first thing. And then we need to put in our mean. Our mean is 28. So we put in 28. And then let's put in the standard deviation, and our standard deviation is 13. So this is the relevant information that we have, and this is exactly what we need in order to calculate the variable. So then let's just click OK, and here it will just say, okay, we just computed this variable, and the real place that you're going to find the answer is in your data set. And if you go down all the way to the right in the data view of your data set, you see the probability. So here it says 0.32. So that means that the probability that x is less than 22 is equal to 0.32. And if in the exam they ask you for a 3 decimal place or 4 decimal places, you can just click on any one of these values. They all equal the same thing. You can click on any one of these values, and if you look in the like little space here, kind of similar to how it is in an Excel file, here it has a more in-depth decimal count. So here, instead of just saying 0.32, it says, 0.3222, like et cetera, et cetera, et cetera. So this is where you can look if you need a more specific decimal rounding rather than just two places. So this is where you can look for that. So this is the case where x is less than 22. But what if it was greater than 22? So what if we were looking for an area to the right of an x value and not to the left? So just how we would solve this type of probability by hand, all we need to do is just take 1 minus the probability that x is less than 22. And that will get us the answer of, that will get us the probability that x is greater than 22. And so whenever we do so, all we need to do is just put in the same exact information, except for this case, since we're looking for the probability that, let's say, the probability that x is greater than 22. We are looking for this, but in SPSS, again, as a reminder, it only finds areas to the left. So if we wanted to put this in SPSS, we have to put 1 minus in front of it in order to get the actual probability that we want. So if we put 1 minus and then keep all the other information the same, because we're looking for the same x value, just in an opposite inequality sign. So let's put probability 2. So this is the only thing that we need to change, 1 minus the CDF normal, and then we click OK, and it will execute this new variable. And if we look in our data set, probability 2 is 0.68, or if you wanted to round it to like a third decimal place, it would be 0.678, and that is our probability that x is greater than 22, so the opposite inequality sign of this. So that's how we would run this if we were given the x value and not the probability, and we had to find the probability. We use CDF normal for that. But what about the other case in terms of finding, using SPSS for probabilities? So the other case is whenever we have to find the x value given a probability. So in this case, it gives us a probability of 0.77, and it's asking us what value can we put in here so that the probability equals 0.77. So again, we have the same exact information, the 28 and the 13, but in this case, whenever we compute the variable, we are going to use inverse DF. And what this inverse DF means is just basically saying, oh, okay, you gave us the probability and we need to find the x value. So we're doing the opposite of what we would normally do in a CDF or CDF normal. So here we go inverse DF and then IDF normal, and we insert again the relevant data and we run it. So let's do that for this example. So here, let's go to transform, compute variable as always, and we're going to find probability 3. And in this case, we don't use CDF normal, we use IDF. So we have to scroll down to inverse DF, and then we go to IDF normal. So here we double click on it, and it shows up here in our numeric expression box. And here again, it tells you which values to put where. So here, instead of the quantity this time, like we did with the last example, here we have the probability. So the rest of the things are the same, mean and standard deviation, but now we insert the probability because that is what is given to us, not the x value. So in this case, our probability is 0.77. So let's put 0.77 into the information. The mean is the exact same. The mean is 28 and the sigma is 13. So mean is 28, sigma is 13. So this is what we would plug in for the IDF normal. And again, we can just plug this in and not do 1 minus or anything because the inequality sign is the way we want it. We want it to be a less than sign. So in this case, this is totally fine, and all we need to do is just click OK, and it will compute the variable for us. So now we have given SPSS the probability and are trying to find the value associated with that. So we check our table and we see 37.61, or more specifically 37.60500, etc. So that is our x value. So going back to our question, that means that the probability that x is less than this 37.61 equals a probability of 0.77. So when x is less than the value that we just found, the probability that it is less than that value is 0.77. So that's how we do that in SPSS. And again, if it was the other way around, you would have to do it similarly to how we did it in class. And the answers for that are in the lesson slides. But yeah, I don't want to make this video too long, so just double check on those lesson slides. It's in lesson 2 underneath Probabilities SPSS, and that shows the workings for how you would approach this if the inequality sign was the other way around. But yeah, that's going to be it for today's video. Again, stay tuned for more SPSS videos. I'm going to have 2 more videos, one over t probabilities, so computing variables except now with t values and using alpha. And then the other video is going to be over doing a t-test and finding confidence intervals with that t-test in SPSS. So those are the other 2 videos that I'm going to be doing for y'all. But yeah, thank you again so much for watching. I really hope these are helpful to y'all. And yeah, I hope you guys have an awesome day. I will see you in the next video. Bye.